Okay, I guess we are all here, so let's continue. I know I'm a bit explaining this maybe too much, but I know from experience that this can be a little, this grouping thing, this aggregation that we are going to do might be a little abstract. Well, the more you do it, you know what you're exactly doing, but at the beginning it might be the abstract. I'm trying to make this a bit more tangible for you. So what we are going to do now is like imagine you have data. You can think of your data as points. So you have a bunch of data points, like data rows. Now we are going to group them. And for grouping, then you have to have a criterion, like based on what do I group them? They have to have a common attribute. So if you're going to tell Python, okay, this is one group, this is one group, one group. So they have to have something in common, these that fall into the same group. So this corresponds with what we have in our data. So we have our data. Now we just created this MMDD column. And then we have these 2,000 rows of data, each having temperature recordings for each hour of the day for the 3 months. So in our MMDD, we have many different values. This is just an example. So I'm going to group values based on the day. So what we have calculated before the break is this MMDD. So now I'm going to tell Python, or Pandas actually, that, okay, all the rows that have the same value here, so meaning that they're from the same day and same month, they are just all in one group. So this is what we are trying to achieve. So we have per day group. So this can be anything. Like in our case, this is very often if you're doing GIS, it can be grouped by some geographical attribute or whatever column you have in your data. So this is basically what we are trying to achieve right now. And with Pandas, it's fairly easy to do that. So let's see how we can do that in Pandas. Okay, so do we all know what we are trying to do? Okay, great. So in Pandas, there is a method for doing this, and it's called group by. So data frame.group by, and then you provide a column based on which you do the grouping, a bit similar to what I drew here. So in our case, we are going to group by, use the group by method to calculate average temperatures for each day of the month. So we are doing the calculation based on, so we are grouping the data based on months and day, and we already have a key value for that. So we have done the hard part maybe. And then calculate the average for each day. So each group, when we do the grouping, each group will be 1 day in our data, and then we are going to calculate the average per day. And then we are storing those values into a new data frame. We will call it daily_data. So this is what we are going to do in the rest of our time today. So just to remember what we have before we start doing the grouping, let's print the number of rows in our data. The code is typed in, so you don't have to do it. So as you probably remember, we have 2,208 rows in our data. And then let's also take a quick look at our data ahead. And this is what our data looks like. And these are the new things we calculated, the date. And we are not going to use that, but we have the MMDD somewhere. I don't have that column, didn't I run the cell? Ah, okay. Yep, okay. Yeah, so let's just continue. Yep, with that. Yeah, so we have quite a few rows of data in our data, as we know, and we have many observations per day. And our goal is to create an aggregated data frame that would have only 1 row per day. So that's what we are trying to achieve now. So to condense our data to daily average values, we can group them based on a unique month-day combination, which we have already calculated. So let's get started and see how this grouping works. So grouped. So I'm going to create a group, and I will name it group, and we will see later what this means actually. But this is how you start your grouping. So data.groupby. So that's the method coming in the Pandas package. And then here you have to provide the name of the column that you are going to use for creating the groups. So it's called month_day. So if you run this, now the group is formed. We will look what this means actually. So in our case, we have already created a nice column storing information about month and day. Just as a tip, you could have done this just like this. You can just provide different columns. So you don't have to always manually do this. We did it manually mainly, well, it's neater and also to mainly see what we are actually doing. But you can just provide several columns to the group by. So it will do the grouping automatically for you based on the month and day values. But in our case, we have this column that we have created ourselves, so we just use that. But just remember that this is also an option. So what do we get as output? Let's check it with the type. So now we can see that we are actually getting a new data type. And it is a group by, a pandas group by object. Yeah, we will get there. But what you get as the output to the group is not the groups yet. It's a group object. You have to iterate through that to see the contents. Okay, so the output is not a group yet, but a group object that has other things in it. Let's check the length of the group. So the length of the group is 92, which makes sense. We have 90, so now the grouping is made and we have 92 groups, which makes sense. We have 92 days in summer from 1st of June to end of August. So I guess it seems that the grouping has worked well and we have managed to group our values to days. So the number of days, which is 92. So it makes sense. So another thing, before we look at our group, let's also check the number of unique values in month day. So the month day is the column that we created based on month and day. It had 92 unique values, again, because we had 92 days. So that's what we got. So if you were using another column in another data set, the number of groups you get is equal to the number of unique values you have in that column, because you're doing the grouping based on that column. So that makes sense. So as I said, that what you get as output in groups is more than the groups. There are a number of things coming. There are also keys coming. So the keys here, let's see what they are. So from grouped, you can access the keys like this. Grouped is the name of the variable we used up there. And then groups.keys. Let's run that. So these are the groups of the keys used in your grouping. And this is the column that we use. So these are the values MMDD we use. So we can access the keys like this. Okay, so now we want to access the groups. So now that we did the grouping, let's see what we actually have. So in order to access data for a group, you have to provide the key. So which group do you want? In our case, each group is a day. So from which day do you want the data? So I will define that key, and I will store it in a variable called day. And remember how our keys work. So you can use it for any date you want. I want to use it for 17th of July. So now I'm going to access one of my groups. So I will just name it group 1. And this is how I access my group data. So I will use get group method. And what you need to provide is the key for that group. So in our case, I'm accessing data from 17th of July. So now if we just put group 1 here, let's see what we have. So yeah, but we all should have gotten the output already. So this is the what I have in group 1. So these are my readings from that day. So I should have around 24 rows here, having all the readings from midnight all the way to the end of the day, every hour. So this is what we have when we do the grouping. So for based on the column you have used, but the keys come from there, and then you can use the keys using this get group method to access each of the groups you have created. So let's see actually what we have in group 1. So what is group 1? I will check the type. So group 1. So it's a data frame. So when you do the grouping and you access the groups using the key, what you're actually getting is the data frame. So it's very handy. So each of the groups is one separate data frame that you can just do whatever analysis you want. And we have been working with data frames. So that's what the output is. So now we want to calculate the average temperature. Well, this is now a data frame, so everything we have learned so far applies to this group. You can just do any calculation. Later we will see how we can make plots and so on. So now I'm going to calculate the average temperature for the columns temp C and temp F. And this is something we have done several times already. So I'm going to get mean values for group 1, which is already defined. And then using .mean method, you can just get the average value for it. And then I'm going to just print to see what we are getting. It's the output, so mean underscore values. So it's just a data frame. I could easily get the average values for temperature C and temperature in Fahrenheit. So now we learned how we can access a single group, but of course we have many groups. In our case we have 92 groups. Very often you have more, so whatever you want to calculate or do, you might need to like have a more automatic way of accessing groups. So of course, like we have seen before, you can do a for loop. So this is how you can write a for loop for groups. The code is already there, so let's just see what we have there. When you access grouped object, remember it was a group by object of pandas. What you get, as I told you, it's not the groups alone. So it's groups and the keys. So when you access it, you get two things as output. So you get the groups and you get the key. So this is how you make a for loop. So for key group in grouped, so it looks at the grouped object you have made, it accesses the group data and also gets the key for each of the groups. Then we are printing the key and the first rows of the data. So, and I've again put a break here because it's a for loop. It will do it 92 times unless you put a break. So now this will only print it for the first row and for the first group in our data. So it's from 1st of June. And yeah, so we are getting the first 5 rows of our group. So if I hadn't put this break, it would have just gone through all the 92 groups and it would be a complete for loop. So this is how you can access. So using the get group method, you can access a single, for example, a single group, or you can write a for loop and go through all the groups you have in your data. So you can see that the output, like you have the key, which was stored in this grouped object, and of course the group data that is coming. So now we want to repeat some of the earlier steps here so you can see better and understand hopefully better what is happening. So I'm going to create an empty data frame for the aggregated values. So I will call it daily underscore data. And I will tell Pandas that this is going to be a Panda data frame. So actually pd.dataframe. Note that the D and F are capital when writing data frame. Then the columns that I have as, well, I want to have the average values of the columns temperature F and temperature C. So what we are trying to do here is to create a new data frame, a new data set with average values, temperatures for the days. So this is what we are trying to achieve. Using the groups we have created, we will create a new data frame that will have days, like each row will be a day with the average values in Fahrenheit and Celsius. So this is an example of how we can use the for loop we just learned. So I will write a for loop now for key in group, in grouped. So this is the beginning of my for loop. Then I'm going to calculate the mean value. So these are the same things we did earlier. Now we just want to do it again and create a data frame. So that's why we are repeating things. So I'm going to calculate mean values, same as we did before. So it's group and then you get it for the mean calls. And then I get the average value for it. Then I want to store, of course, the information about the group, the key. So in our row, I want to know, okay, this is the average temperature from which day. So I'm going to use my key value, the month day column we had created earlier. So I use the same name and I store the value key in it. So it's the key of the group will be stored there. So next, so I have a row of data, so it's a Pandas series. So now I'm going to turn it into a data frame. So mean underscore values dot to frame. And then I'm going to do one extra thing, and that's to transpose our data. So remember, when you are doing the calculations, these are like this. These are vertical. So we have rows, but we want to put them in one column. So temperature C, temperature F. These are calculated like this because this is how our original data was. Now I want to make one column. So I want the temperature C not to be on, I don't want them to be on top of each other. I want to put them next to each other. So temp C, temp F. So what I'm doing a transpose to just turn it around. So they will become two columns instead of being under each other. I will transpose the matrix or the table. Now let's bring in the aggregated data there. So the data frame was named daily data. And for that I'm using PD, the pandas concat method to join the values, bring the values together. We have daily data row. I will explain what I'm doing here, but let's type it first, then index. Okay, so I did the same calculations that we did before. We calculated the average for each day, and then because they were vertically, they were on top of each other, like a vertical series, then I transposed it to have different columns, and then I just brought everything together using the concat, and then ignore index, meaning that it will just create a new index for you. So it forgets about the original index in your data. So you will ignore what you originally had. You just create a new data frame with new indexing. So this is what we are doing. Now let's see what we got as the output. So this is what we have as the output. So we created a new data set using what we got out from the grouping. So the grouping allowed us to group things, and using those groups we calculated the average temperatures in Celsius and Fahrenheit, and we did a bit of work moving things around to create a new data frame. So this is what we did. We have the two columns, temp F, temp C, and the month day key. So we just created a new data set. So take a minute to just look at the code and see what we exactly did. See if it makes sense. Okay, so let's continue. So now that we have done our calculation, we have prepared our data, now we can get back to the research questions we had at the beginning. So see how the data looks like, how many hot days we have had in Helsinki, and so on. So let's continue. Detecting warm days in July. Now that we have aggregated our data into daily level, we want to sort our data, our results in order to check which days in July had the warmest temperatures on average. And sorting is something that we already tried last week. So let's just try this for July. So I'm going to extract July days. So I will select the rows from my data where the month equals 7. So I'm getting all the data rows from month 7, which is July. Let's put this J capital because that's how we use it later. So let's remain consistent. So now we make a subset of our columns. Just we are only interested in temperature F, C, and month day. So let's just select those columns, make a subset. So now we want to do the grouping again. So we create the grouped object again, but this time only for July days. So last time we did it for the full data set. Now we are just doing for a subset. So July days. And again, I'm using this group by method. And similar to last time, I'm going to group it by month day column. Then again, similar to what we did before, I'm going to get the average values for July. So I'm going to call it daily mean underscore July with J capital. And it's going to be the group mean. So now let's print ahead to see what we get as the output. So daily underscore mean, which we just created, underscore July dot head. This J was capital, I guess. So now we repeated the same process. We got the average temperature for only month July. So now I want to just quickly look what are the hottest days in July. So there are many ways to do that. We can make selection, we can do whatever, but the easiest way to just visually see what are the hottest days is of course to sort the data. Then from the head I can see the hottest day will be at the top. So let's do this together. We have tried this already last week. So I will use this data that I have, daily underscore mean underscore July. And I'm going to sort it. I'm going to sort values by temperature C. So I'm putting the rows in order based on the values in temperature C, and then I'm setting ascending to false. And I'm going to get ahead for top 10 rows. So of course, now it will sort our data in a descending way. If you set ascending to true, of course, the order will be different. So I want the hottest temperatures to be on top, so I'm doing it like this. So now the top, so it's in a descending order. So the hottest day is on top. So the hottest day in July in last summer was on 26th of July, and it was 22.7 degrees Celsius. And you can see in order what were the highest temperatures. So now we want to actually see if we did break the. So in Finland as whole, we had 66 hot days over 25 degrees. But did we have as many or any value close by in Helsinki alone? So let's look at our data. So I'm going to use data.head. So this is what it looks like. So this time I'm repeating the same thing, the grouping and everything. But if you remember last time we got the average values for the days. So that Yle article we looked at was about highest records. So it was based on the highest temperature of the day. So it wasn't about the average day of the day. Did we break the 25-degree record on that day? And that's based on the maximum value of the day. So last time when we did this calculation, we got the mean, the average. Now we are repeating the same thing. So it's the exact code as we just used last time. Last time we used it for July. Now we are using it for the full data for the whole summer days. And instead of mean here, I'm using max. So I'm doing everything the same except that I'm getting the maximum temperature for each group. And each group is a day, so I'm getting the maximum temperature of the day. Everything else is the same as what we had before. So another thing I'm doing here, I'm renaming temperature C. So the value that will be in the output in temperature C is the maximum of the day. To just avoid confusion, I'm going to rename that column to max underscore C. So again, we will have groups. We will have 92 groups. Last time, each group had the average temperature because you are bringing together 24 values from the day. So you have to choose how they are brought together. Is it average or what? This time we are using max. So for each day, the temperature C value is actually the maximum value of the 24 readings of the day. And then I'm just renaming it to make it more understandable. So let's just run this and see what we get as the output. So yeah. So we have a column max C. That's the maximum temperature of the day. So does it make sense or is it confusing? So everything was exactly the same. I just, for each aggregated group, I used this time the maximum, not the average. So now what I'm doing, I'm trying to test that hypothesis or that question. How many hot days did we have in Helsinki? So the code is already written there. So I'm counting the number of hot days. I have a condition there. This is something we learned last week. So I'm checking the values in the column max C, which I just calculated. And I'm testing, like I'm counting how many times it has been bigger than 25. And then I'm just printing the output in a F string. So let's just do that. Yeah, so in Helsinki, during like summer, we had 12 days where the temperature exceeded 25 degrees. So in the whole country, we had 66 days at least until 5th of September, where the temperature was over 25 degrees. But if you only look at Helsinki, it's been only 12 days. So we did this analysis to test this. So now we know the answer for Helsinki. We know that, okay, we didn't break the record as many times as we did in the whole country. Now we want to test it for other cities. So we did a lot of things. We have been doing things now, of course, a bit slowly, but we have been doing things now for an hour or two. So if you want to repeat this for this cities, other cities, you don't want to just type in everything again. So that's why we are going to automate things. And for that, we are learning a new method, which is simple but very effective and useful. And that's a new library called Globe. So Globe is a library that allows you to go through files that you have in a folder. So if in your folder you have many data files, like in our case, if you check this data folder, we have 6 cities. So I want to iterate through that. So one way is, of course, you put manually the link, the path to the file. But do you want to do that? Probably not. Imagine if you had thousands of CSV files in this folder. So this Globe allows you to iterate through all the files in the folder and then repeat, if you want, the same calculations for them. So this is what we are going to do. So let's see how this Globe works. So as usual, you need to import the library, Globe. Then I'm going to create a file list of that folder to just see how it works. So from Globe, I use the function Globe. And then here you have to provide the path to your folder. So these are, I don't remember if you have seen it before, but it's a good habit. In Python, if you are giving path, if you're typing a string as path, it's a good habit to put R. So it's telling Python that this is a raw text. So if there is some space in the name or something, it just helps Python read the path a bit more easily. So probably nothing happens here if you don't put it, but it's a good habit to have it before the file path. So what I'm doing, I'm saying that, okay, I'm looking at my data directory. So inside my data directory, then you can, here you can give a bit of like, make it more specific what kind of files you're looking for. So the asterisk here means anything. So it can be anything followed by CSV. So I'm looking for files that have any name, but at the end they have CSV. So imagine if in my folder I had a bunch of also text files that I don't want to look at. With these, I only get a list of the CSV files. So if you check the documentation of Globes, there are a number of ways how you can like modify this. So if I was interested in files that start with the letter A, then something random in between, that CSV at the end, I could have put an A here. So you would have looked for all the files that start with an A, then there is something, then CSV at the end. So it allows you to filter the files, which is useful. In our case, we just have 6 CSV files and we are going to list them. So let's just run this. So now we want to see what we have there. We already have a F string there, so number of files in the list, and we have the length, and we have actually the file list printed. So let's just run that. So we can see that we have 6 items added to the list, which makes sense. We had 6 CSV files in that folder. And you can see the name. So we didn't type any of this. It just got it for us, so automatically. So imagine how much trouble and time it saves you if you have thousands of files. It just made a path to each of these files. So now this is a list. As you can imagine, we can just make a for loop, go through each of these lists and access those different files and repeat the process. And that's exactly what we are going to do now. So this is an example of how we can loop over this list, something we have seen before. So I can access each file path in the list. Okay, so this is the interesting part. Actually, nothing here, almost nothing here is new, but just maybe one of the first examples how you can see you can automate the process. So these lines of code are all the things we have done during today with this data. So I've just copied them, pasted them here again, with the difference that I've put them inside a for loop. So in the for loop, I'm going through files, read the file path, then opening the file and doing all these calculations. So you see, last time when we started this lesson, we typed in what was the file path to Helsinki. Now the file path is coming from this for loop of lists of file paths we got from Globe. So in the for loop, we get the file path. Let's walk through it. This is what we did earlier. We open the file. We only use the columns that we actually needed. Remember, we did this first thing in the morning today. We also specify what is the null value. It was dash. Then new names. Remember, we renamed our column, so we are renaming it again. Then remember, we created that MD file, MD column. So we are doing it. We convert it to a string. Doing MD with Z field. Remember, we did it before the break. And then we extract the summer days subset, just having the temperatures, doing the grouping, doing the max calculation. We just did that. Doing that condition to count the number of days over 24. So I've just copied everything we have done before. Nothing is new here. The only new thing is that I put them in a for loop. And then I've added this f string because I want this to be repeated for each city and then it repeats. So what I've done here, I put the counter, it's f string, so I put the count of hot days, which I've calculated up here. Another thing I've done here is a station name, just to make it easier. So I'm getting the station name using this split method of strings. So I'm splitting so I'm getting it actually from file path. So imagine, so look, as file path I have these values. So I'm extracting this part of it. This is not a must, I'm just making that output more readable. So I'm just extracting, I'm splitting this text, keeping only this part so I can print it. So this is what I'm doing here. Splitting based on the slash, keeping it. Yeah. And I remove the CSV. So when I split it after a slash, it has like Helsinki Kumpula.csv. I don't want that CSV in my text, so I just replace it with nothing, with empty space. So let's just run this very quick. So it redid the calculation, everything we did today for the 6 cities very quickly. And this is the F string we are printing out here. So in summer 24, there were 12 days with temperatures over 25 in Helsinki. This is what we saw already. For Lappeenranta, we had 17 days, so it was a bit hotter than Helsinki. In Oulu, it was 5 days cooler. In Porvoo, we didn't have any days over 25. In Rovaniemi, 12 days. And in Turku, 2 days. So quickly, we just repeated the whole analysis for the 4 datasets, for the 6 datasets. Yeah, and that was the grouping. That was the aggregation. Are there any questions? You're going to use this in your exercises today. So hopefully this makes sense already, but once you start doing it yourself, you can test different things. Then you will know better what you're actually doing. Now it might seem a bit like too much. So I have a text. This is what I'm splitting based on. So I'm telling Python, actually it didn't work well here. I got data here because I've done this on Windows. This is now running on Linux. So the slash is different, and like it's backslash on Linux. So what I was trying to do here, I want to just get this. So using strings have a method called the split. So you can just say that, okay, split my text wherever you see this. So then it will be split into two parts, before the slash or after the slash. And it will be a list, so it will be indexed. So I used index -1. Remember, in list, index -1 means the last. So I'm accessing the latter part here, this one. So what it should return me is everything after this slash. So why do I put two slashes? Yeah. Yeah, that's the idea. But we put two slash because one slash in Python is like it has a meaning. So remember when we were printing things, we can do this. So it puts a new line. So in Python, a string, a slash is a reserved sign. So if you want like slash as a slash, not as something that does something, then you have to put double. So that's why I have to double.
Can you reverse the direction of the split, like split to the right?
Now it's splitting right, correct, but the problem here is that on Linux the sign is like this, different.
I mean, if I want to split everything after Helsinki, for example,
Yeah, then instead of a slash, you would just put this, for example. You would say split after Helsinki. You can just put this instead of a slash. Yeah, instead of a slash, you can put anything. For example, I could split based on underscore. Let's see what we get if you put underscore here. So now we got Kumpula, Helsinki, because it is split based on this here. So it is split things based on this. So this is index 1, 0. This is index 1. So instead of -1, I could have put, of course, 1, because it's just two items. Yeah, but now based on underscore, I got this. So I just got Kumpula, airport, harbor. So I got everything after this sign. And then here I'm dropping CSV. If you don't drop CSV, the CSV would also appear there. So if you remove this part, if you don't replace it, you will also have the CSV at the end. Yeah, so it's a bit of like playing to get the clean text. And with a slash, you can try like turning it around so it works on Linux, because I did this on Windows. So it's a bit different. Yeah, but this was just to make this text a bit more readable for printing. So we have a bit of time still. We have a few small parts in the lesson left. Let's quickly look at them. So I will go to just the courses website. So interpreting errors. So I'm sure now that you have been working with Python for already about 5-6 weeks, you have seen a wide range of errors, and that's a very normal part of coding. Like you will never write a perfect code right away. You always get some errors. You have to fix something. There's always something. So the main thing, so there's nothing wrong with getting an error. The main thing is to not panic and figure out what the error is. And the errors are very informative, especially like in most, well, all programming languages have some way of showing the errors. In Python, they are quite informative, and they have become even better after Python version, I guess 3.10. There was some major upgrade, and then the errors are a bit more informative. So you probably have already figured out what these error messages you get mean. So they usually look like this. Of course, depends on what environment you're running your code from. The styling might be different, but the text is the same. So this is from Jupyter Lab. So it tells you what cell you had an error in. So imagine now, later on when you're working on your final project, you will have a bigger Jupyter notebook with many cells and you do different calculations. So it tells you, okay, when you run this, there's a cell number, this, producing an error. And it shows you that this number has an error. So if you want to see numbers, you probably have noticed in view in Jupyter Lab, you can have something like this, show number line numbers or something. Yeah. So this is handy. So if you get an error, then you see, okay, it's from line number something. So that's an important part of the error message you get. Where has the error happened? If it is in Jupyter Notebook, the number of cell and the number of line within that cell. Then it also shows you which line has produced the error and caused the error, and then type of error. This is another important part of. So there are different kinds of errors. Here we are seeing a syntax error. It means that you have probably, there's something wrong with the language. So you have, very often you have a typo or just syntax is wrong. So there are some details about the error. So in this case, we hadn't closed this string. So we have this double quote at the beginning, but we didn't close it at the end. So you're getting a syntax error. So there's a problem with your language, the language you're talking to Python with. So you have to fix it. So it has useful information. So sometimes the errors are a bit more complex, like especially if you have bigger program. If you have just one line of code, you get a single error telling you that, okay, you haven't closed the quotation mark and that's it. But when you have bigger programs having several steps, like what we did at the end, then you get this thing called traceback. So it's a collection of errors because you have made one mistake somewhere and that might lead to errors along the way. So it gives you a traceback of where things have gone wrong. So let's look at this example of traceback. So it looks a bit longer, but the error is just in one place probably. It's just cause a chain of errors or actions here. So this is called a traceback. So it gives you a hint where to find the problem. So the error has occurred on line 5 here. So if you can, where you have this, so it has happened here. But the traceback is telling you that the problem is not actually here, because this is using a function. The problem is inside the function. So if you look at the traceback, it's saying that, okay, the error is occurring at line 5, but the root of the problem is actually on line 2, because this is using the function here, and the function is up here. So the error is actually somewhere here. So you're getting a type error. You're dividing string by integer. So this is a traceback. So it gives you a number of like chains of things have gone wrong, and it gives you an idea. So if there is a problem here, so you don't need to look for problem here necessarily, because the root of problem was up here. And this is what the traceback is telling you. The error happened here, but the root goes all the way back up to line 2. So also you might have different scripts. Remember, was it week 2 or week 3, we were working with modules and like scripts. So if you have an error happening in another script, then this traceback tells you that, okay, it's coming from there. So tracebacks are useful for handling, finding the errors. So there are many errors in Python that you can encounter in your work. Some of the common errors, index error is probably something you have seen when you're working with lists. You might get index error if you're like make a mistake with errors with indices. So that's one common error you see. So index error. Then there are name errors. And that happens when you have not defined the word. So if you try to call something that you have not previously defined, it can be a function you haven't defined, a variable, whatever, then you get a name error because Python doesn't know what you mean by that word. Then in Python, we have already seen that indentation is a big part of Python when you're making blocks of code, when you're having like if statements, for loops. So if you get the indentation wrong, like for example here, this print should be under city. It should be in the same level of indentation. But this is probably something you have seen. You will get this indentation error. there is some inconsistency in how you have used indentation in your code. So this is another common type of error you see. Then type errors are again common if you're doing some calculation that is not compatible. For example, if you're dividing a string by integer, so that's not going to work. You get a type error. And there are many other kinds of error. Of course, there's a link here to some resources you can check and learn. Of course, when you're doing your work, you see all kinds of error, and then you can learn what that means. But these are the most common ones you usually see. So today our good coding practice is also about a bit like errors and how to handle them. A good habit when programming in Python is use of assertions. And we are going to use this a lot, especially like some of you who will continue to the second part of the course with GIS. We always use assertions. Like when we are working with coordinate systems, we always check, okay, are these in the same coordinate system? Because if you don't check, then you do some analysis and you may not necessarily get an error if the coordinate systems are not matching, but then the output doesn't make sense. So you want to add checks in your code to make sure you don't make such mistakes. So this is the idea of assertion. So how does assertion work? To write an assertion, looking for an example here. Okay, so this is how you write assertion. So you have a function here that is converting kilometers per hour to meters per second. So you want to make sure that the value that you get as input is bigger than 0. So you write assertion like this. So you write assert, and then you have a condition. So the speed, which is the input of this function, should be greater or equal to 0. And then if that condition is not valid, if the user has put a number -10 as a speed, the code is going to break and show you this message. So this is how you write assertion. Assert some condition, comma, and then a text. This text will only appear if there's an assertion error. If you don't meet this condition, then you will see this text. So in this case, we have tested this with a value of -27. So as you can imagine, this condition is not valid. -27 is smaller than 0. So when you run this, you get an assertion error. So you are producing error, because if you don't put that, it will do the conversion. Python has no problem if your speed is negative. It just does the math. The value may not make sense, but it just does the math. So assertion is useful in situations where you don't get a Python error, but your results would be wrong or may not make sense. So you want to check for the input. So that's why it's important. There are some good habits how to use assertion. So do not use assertion for things that would anyway produce an error. So if you divide string by integer, you would get an error. So you don't need an assertion for that, because Python will anyway not execute that code. So put assertions in places where you would not get an error, but if someone provides wrong input, you would get an unexpected or wrong outcome. So it's a good habit to put those checks in your code. So in this case, if you put an assertion checking for the type that is integer and not a string, that doesn't make sense, because anyway you would get a Python error. So that's how you should use assertions, for things that do not cause error but can mess up with your results. Yeah, and there are links if you want to learn more about assertions. There are links. Then a couple of things related to debugging, again continuing with errors. So debugging means that, okay, you have some error, you have some small problem in your code, and you have to solve it. And that's a big part of coding. You always have something wrong somewhere in your earlier versions, then you have to just figure out. So we already saw that, okay, how can we decipher the errors that we get from Python? So that's the first step. You know what's wrong, where you have the problem. And once you have it, then you have to have a strategy for solving it. So the general recommendations for debugging your code, so you have a bug in your code, you want to debug it, get rid of that bug or problem in your code. So these are some recommendations. Test your code with known outputs. So like you saw, today we made a very simple function for converting Celsius to Fahrenheit. It was very simple, but still I tested it. Like I wanted to see if it really gives me the real value. I tested it with the value I knew. I knew that 0 degrees Celsius is 32 degrees Fahrenheit. So that was to validate my thing. So if you have some more complex function, that was very simple. If you have a more complex function, test it with something you already know. So you can say, okay, is it giving me the expected outcome? So that's a good tip when debugging your code. Just test that the results make sense. Make your code crash quickly and regularly. This sounds weird, but it will save you a lot of time. Like, if you have an error, like with these things, they are quick. Like what we did today, it was a small data set, it runs fast. Imagine you're doing an analysis on, I know, 1 million CSV files. This is often the case, like you have thousands of files. And the process takes, I don't know, 1 hour to run. And you only get the error after 40 minutes. But that's not good, because every time you test your code, you have to wait for 40 minutes to see that error, then try to fix it. So try to make it so that the crash already happens earlier. So for example, when we wrote the for loop today, we put a break. So if it's a long for loop that takes an hour to complete, I don't want to wait that long. If there's an error, I want to see it right away. So write your code in a way that if it's going to crash, it should crash earlier, not that you wait 2 hours and then see it didn't work. So that's another important thing. Then make small changes and track them. So if you're writing a lot of, like, usually it's good to use this like a snowballing approach in programming. So you put things, then you add features. So you make the code work first, put the main functionalities, then you add things. So add things gradually and test if what you did caused an error. Because if you write a lot of things, you add a lot of parts without testing your code, and then you get an error, then it's hard to know that, okay, which of the things I recently added caused the error. So if you do it gradually, then you know, okay, I added this line and this, now I have this error. So do it regularly. And one thing that is useful when it comes to regularly checking your code is GitHub. It's something we have been practicing with this course. So if you do these regular commits, so if you make some change, you do a commit, and then if something breaks, then you have this history of changes. You can always revert to a state where the code was working fine. So with bigger programs, you will see that this is very helpful. Otherwise, it's just hard to know what has gone wrong and at what part. So it will save you time. Yeah, and if you have a very complex data set you're working with and you're testing it, it's good to start with a more like simple data file to see how things work before you provide a full data set. Again, if it's a huge data set that takes hours to process, then start with a small subset of your data to see if things make sense. Yeah, so that was about errors, debugging, tracebacks in Python. Do you have any questions? If not, we can take a very quick look at the exercise for this week. So you have 3 problems that you will be solving, and they're rather similar to what we did today. So we will work with weather anomalies, but the data is coming from a different source, so it's a different format. It's not as clean and easy as what we did during the lesson. So, well, it's similar, but it's just a bit different, like how the dates are formulated, but also how the missing value. There are a lot of missing values in the data. So for your first problem is to read this a bit like trickier data file. So it's a TXT file similar to what you worked with last week in the lesson and exercise. So you will work with that TXT file, you will read it. So there are some missing values and there are some information here. You should handle those missing values properly when you're reading. So that's the first part of your problem, to read that data properly. Yeah, so the objective in this exercise is to identify weather anomalies. So when the temperature is very different than the record. So the first part is to just read the data properly and handling the missing values. The second part is to calculate monthly average temperature. So we create a baseline based on which we will do the comparison to see if you have any anomaly in the data. So we create that monthly average temperature. So we do that grouping similar to what we did today. Today we did it daily basis. This is on a monthly basis. You do the grouping, you calculate the average, and then you calculate the differences to see, compare the temperature in other months to the baseline to see where you have the anomaly. So that's the exercise. So very similar to what we have done today. And then there's a third optional part where you can try doing the same thing with AI. It's optional. But if you do it, then try different prompts and see what you get as output, then report to us what your prompt was and what you got as the output. And in case you need to provide additional prompts to make ChatGPT or whatever tool you're using to understand what you mean, then also tell us how you did that. And that's it for the week. If you have no comments or questions, then we can wrap it up here and see you next week.